So I'm not sure how significant this video is going to be for people, but just in case something got missed here, I'm going to do a little video about law of sines in the easiest context, which is angle, side angle, and angle, angle, side. So for starters, let's just talk about the anatomy of the way that we phrase these questions. Usually in a geometry class, we'll call each vertex by a capital letter, capital A, capital B, and capital C. Those are the coordinates right here that make the triangle. A decision was made a long time ago that we would just structurally make the side lengths named by the vertex that it's across from. So little a would be opposite big A. And so what we learned a little while ago was that the sine of capital A, which is an angle usually measured in degrees, divided by the side little a, which is across from it, would be the same as the sine of big B over the side opposite it. And by extension, the same thing with C. And it's strange to write it in this format because we have three different pieces, but you can take any two at a time. And as it turns out, this is very useful for solving ASA triangles, AAS triangles, and side-side angle triangles. This is one that I will deal with. It's called the ambiguous case. And I will deal with that in a separate video. Now, the idea of doing this every single time is that the relationship between big A and little a is across from each other in the same way that big B and little b are across from each other, and the same thing with letter C. So by setup, the sine of A over A equals the sine of B over B. They're always set up from each other in that way. So here would be a simple, quick example of how that would play out. So when I draw these triangles, I don't make any effort at all to make them to scale. I just kind of draw something and I label it however I feel like was appropriate. This says angle A is 37 degrees. Notice I put or alpha because sometimes we'll use Greek letters. And it says angle B, also known as beta, would be 76 degrees, and side C, which is opposite big C, is going to be 12. So what you can see is this is an ASA setup. So that means the law of sines is going to work perfectly fine for it. So the first thing that I know is that since there's 180 degrees in any triangle, I could take off the two that I already have, which is 37 and 76, and I now know that this missing angle that I have right here, which I'll put in red to show this is not part of the original data, is 67 degrees. So I now can say that the sine of 67 over 12 would be the same as, let's say, the sine of 37 over little a right here. Now, if I do a quick cross multiplication, this is what would show up. And so all I need to do is take 12 times the sine of 37 and divide it by the sine of 67. So that was 12 sine 37 divided by the sine of 67. And as long as I'm in degree mode, which I am, this result right here should be the value of A. So side A is 7.845. A equals 7.845. Now, generally, the instructions on these problems are to solve the triangle. Sometimes it's one facet of the triangle, but it's often the entire solution. So I have all three angles. I have two of the three sides, so I have to have one side to go. So we would just go use the law of sines one more time. And I could say the sine of, let's say, 67 over 12 would be the sine of 76 over letter B, very much similar to the problem that we did a moment ago. So 12 times the sine of 76 divided by the sine of 67. And that's going to give me my answer for letter B. So B would be 12.649. Now, there isn't a whole lot that we can do to say how perfect these answers, but you can always see that the smallest angle should always be opposite the smallest side, and the largest angle should always be opposite the largest side. There's another thing that you can do that I mentioned in class, and that is, hold on, I accidentally just launched something here. I need to make sure it stops. wrong. Please stop. Okay, there we go. And that is if you do a quick Google search to here and just look up triangle solver. And if you do a quick triangle solver, my favorite is Project Nayuki right here. And so if you just type in the data that you know, so for this problem, I gave us that angle A was 37. I gave you that angle B was 76. And last but not least, we said that side length C was 12. You'll notice it says it was in fact ASA case like we thought it was, and it solves the triangle, and all of the data that we have matches perfectly what came out here. So that tells me I did okay. And I'm actually very, very excited to let you use that as a tool to double check your work as you go. So coming back to here, this is the last problem that I have. Again, by looking at it, you don't really know exactly what you're looking at. But just like the problem a minute ago, I'm just going to make a random triangle. And this says side C is 104 degrees. And I actually like the fact that I made this look bad. That's an obtuse angle. It doesn't look like it, but it is. Angle B is 45 degrees. And side length B is 20 inches. So just like that previous question, the first thing that I'm going to do is I'm going to find this missing angle that's right here. Let's take 180 and take away 104 and take away 45, and I'm looking at 31 degrees missing. That was pretty easy. Now, here's where I'm into the fast stuff. I could say then that the sine of 45 over 20 is equal to, let's say, the sine of 31 over little a, very much like the previous problem. And then secondarily, I'm going to say the sine of 45 over 20 is equal to the sine of 104 over, I guess it would be little c. And so both of those are problems that I would solve separately here. 20 times the sine of 31, see I'm cross multiplying, and then I'm going to divide it by the sine of 45, and I just got that the value of letter A is 14.567. And in a similar way, 20 sines of 104 divided by the sine of 45 tells me that little c right here is 27.444. I'm going to go ahead and transfer those onto my picture. That's 14.567 and 27.444. And again, the largest angle is right here. It is definitely opposite the largest side, etc. And that's how we quote unquote solve the triangle using law of sines for both the ASA case as well as this one right here, which was angle side. So hopefully if you had any doubts about that or forgot how to do that, that's how we're going to go about that. So I will see you back in class soon. Have a good one.